provide some introductions on who I am, a little bit more detail than what Adam's offered so far, what shifting left is, maybe a few housekeeping items, and then we'll get into the topics that I believe are related and a result of the profound shift in cloud, those being your CI/CD pipelines and the changes that you get on cloud versus on-premise, cloud native architecture design principles, the concept of DevSecOps, as well as some of the cloud security controls on GCP specifically. But for the most part, when I'm talking about cloud security controls and cloud principles, most of them apply across the top 3 or 4 public cloud providers. And please, I'd much rather be having this conversation interactively. So I know it's been pretty quiet so far. Please jump in there, ask some questions. Thanks a lot, Julie. I appreciate that. Okay, so introductions and housekeeping. I started InfoSec back when this was a thing. I'm assuming most of you probably don't recognize what this object actually is, but it's actually a key management device and a paper tape key reader. I started off in the US Air Force in 1992 as a crypto tech. And just something to keep in mind, that paper tape, even though it's pretty short, it did contain a key that was roughly 120 bytes. The key slots were 128 bits, 128 bits in total, 120 for the key material and 8 bits for the checksum. And then I made reference to shifting left. And shifting left is this concept really based off of what was originally Microsoft's SDL, or Microsoft's security development lifecycle. And while the SDL was a really great concept, it really didn't make much progress beyond the security community itself. And so what I'm really hoping is to take this concept of shifting left, which was first identified or defined sometime out of the DevOps report, which comes out from the DORA organization, that security really needs to be a shared responsibility, and it needs to be much more pervasive throughout the life cycle. And so the idea of shifting left is that we're moving it farther left into in that pipeline, whatever pipeline it might be, a business pipeline, your typical CI/CD pipeline or deployment pipelines. It's not so much a downstream phase. I think that's where we get into trouble, is when we only rely on it as a downstream phase. And oftentimes the rest of the business sees security as a blocker rather than an enabler. So with that, from a housekeeping standpoint, there are a few terms I'll be using, and TLAs, or 3-letter acronyms or abbreviations. First and foremost, public cloud providers, AWS, Azure, and GCP. Of course, GCP being the Google Cloud Platform. Virtual machines, we'll be talking about containers, making reference to serverless, as well as GCP being the platform, as I just made reference to. GCE being the Google Compute Engine, which is the managed virtual infrastructure for virtual machines. GCS, which is our Google Cloud Storage or our cloud-based object store, as well as K8s or Kubernetes. K8s simply being the abbreviation because there are 8 characters between the letters K and S. And from a bare metal standpoint, hopefully those of you in this session have a level of appreciation of building bare metal servers some time ago, if not your own laptop or personal workstation sitting on your desk, ultimately through evolution and maturity to a virtual machine. Virtual machines came out because we wanted to better leverage and share the infrastructure and get more efficiency out of the underlying hardware that we had already purchased or capitalized. And then even further, we then created containers. By we, I'm meaning community, not Google Cloud specifically. And so this kind of gives you an idea as to where those dashed lines encompass from bare metal, what you're responsible for, from a virtual machine, what you're responsible for, and ultimately the container, where the container is simply a packaged image or object of binary files of application code and dependencies that will run within a container or cluster environment that can support the operating system and the hardware. And then also there's a reference on serverless, and serverless is really the next step beyond containerization. It leverages containerization, but rather than you having to manage the cluster or the infrastructure where those containers are running, your cloud provider or your service provider would end up managing that infrastructure for you. But this is really to benefit not only security, but also to benefit the development organizations, your software developers, your software engineers, where you can promise them, no servers. They don't have to worry about the infrastructure. It's idiomatic, meaning it just feels natural. What comes natural to them? Are they writing in Python? Are they writing in Go? Are they writing in Java? And then again, being able to take advantage of event-driven patterns, and you're free from lock-in with any particular vendor. And most of the cloud providers can offer this today. And then we can get into CI/CD, or continuous integration and continuous development. And when I say continuous, I do mean continuous on a daily basis. So we're not about the waterfall methodology where you're going to go ahead and make code changes. You're going to keep them all local. You're not going to do a commit on a daily basis. You're going to keep it all on your laptop or your workstation and so forth. What we're asking you to consider is to do frequent updates, frequent commits, so that we can go ahead and do those PRs and those merges into mainline or into some development line on a regular basis, and regular being daily. And what we found at Google is that when you do that on a daily basis, you're really reducing your risk or your exposure on deviation or folks really forking off into the wilderness. And so your normal or your typical release process might look like this diagram here, where you have your developers running their local unit tests and so forth, and then doing some sort of a commit into the code repo, and then ultimately potentially into a container repo after a build, doing some sort of exploratory test, preferably in an automated fashion. If you can automate, you can reduce the introduction of manual error or human error rather. And then again, from your nightly exploratory tests into your staging and integration tests, and then hopefully thereafter, once approved, on into your production environment, which may be in a single region, a single zone, or otherwise. I'm not seeing any questions yet, so I'm assuming you're all following me. And then along with that release process, this is your typical vanilla CI/CD pipeline, where we take that source code, we take that collection of files from some repository. It could be Git, it could be local, it could be pretty much any system, but the triggered event or trigger that's created as a result of a commit event, some system is watching, you typically go ahead and perform a build and initiate your tests. We're considering this piece of the pipeline the CI piece, or the continuous integration. And then from that build, you end up with a collection of binaries. It might be a single binary, might be a collection of those binaries that land in some sort of an artifact repository or artifact storage. And then oftentimes, once you have it in that artifact storage, you then need to deploy, whether that's into a test, staging, or production environment. And so this piece of the pipeline is referred to as your CD, or your continuous deployment. So upon a propagation of that source code to an artifact, signing, verification, attesting, and so forth of those artifacts, and then ultimately into some environment, until ultimately it gets promoted into your production operational environment and monitored as such. What I'm asking you to consider, and what we're practicing here and asking our customers to consider at Google Cloud, is something closer to this vision of a Google Cloud software supply chain, where upfront you're relying on safe-based images, meaning any of your third-party dependencies or external dependencies, or even internal dependencies, you're vetting them and performing a risk assessment before you actually consume them and extend them or build on top of them. And then you can go ahead and enter into what would have been that vanilla pipeline. But along the way, in addition to the artifacts in there, we're going to go ahead and ask that you consider using an artifact image metadata store, something that allows you to go ahead and enrich the attribution or the attributes that you're maintaining against those artifacts. So in there, maybe you do a build and you're going to perform a vulnerability scan against that build. And you're going to look for CVEs that are of high or critical severity. And if that artifact has any high or critical severity vulnerabilities, you can then by policy make a decision as to whether or not you want that to continue to propagate through the pipeline and land into some operational environment, or you're going to kick it back into your DevOps and your development organization to ensure that those vulnerabilities are mitigated. Otherwise, assuming it has a score that meets your appropriate risk profile based off of your business needs, you can then sign it, attest that you're okay with that score, and sign it for the appropriate landing zone, meaning you want it to go into test only, or you want it to go into staging only, or it's actually ready for production. And so this binary authorization layer in this process is really your admission control to ensure that no unsigned or unattested binaries are deployed into your production environment or even into your test or staging environments. Okay. And this is just an example of a pipeline and showing some of the actual tooling that might be available within GCP or your third party and open source solutions along the way. Okay. And so from a proactive security controls upfront in your development and design process, I'm asking you to consider, one, perform a threat model even before you hit the keyboard and start entering code or designing your actual code itself. What's going to be the impact? What are the inputs? What are the expected outputs? What business logic is going to be applied? And what are the risks and concerns there? Once you've actually written the code, here in number 2, I'm asking you to go ahead and perform a code review and consider a SAST or a static application security testing opportunity here so that you can actually run it through. There's a number of different open source solutions. There are a number of different commercial solutions that are out there, but the same way that our development community has truly embraced styling and conventions with regards to pre and post submit tooling, let's put the security controls up front as well. Just the same way that you can do a style check and enforce 3-character or 3-space tabs, why not go ahead and look for bad coding practices? Do it up front. It'll save you tons in your pipeline. Third, once you actually have that artifact built and you can go ahead and deploy it into some test environment, let's go ahead and perform application security testing, or DAST, your dynamic application security testing, where if this is a web service or an API, you can actually exercise it from a testing framework, open source, commercial, or otherwise, that can actually exercise those endpoints and the full application functionality there. In addition, on number 4, go ahead and perform vulnerability management, as I made reference to earlier in the CI/CD pipeline, where you're scanning for CVEs or you're scanning for local vulnerabilities that you're aware of. Maybe you have different practices, or maybe you're using libraries that haven't gotten the attention of community security researchers. So there may not be any existing CVEs out there. And when I make reference to vulnerability management here, I'm also including config management and patch management, because the objective at the end of the day is to end up with some immutable artifact that gets deployed into your appropriate environment. And by immutable, meaning once deployed, you're not making changes to it in its operational state. If you need to make changes, you're going to make those changes earlier on in the pipeline and redeploy. Okay. And so we can go ahead and move on to the cloud native architecture design principles. Again, this is something to consider before you're actually writing code. And this is not just for the developers. This is for your DevOps team. This is for your cloud ops team, the teams that are ultimately going to be responsible for the infrastructure, for the cloud environment, as well as the security monitoring and response within that cloud environment. So at a high level, a well-architected cloud native system should be largely self-healing, cost efficient, because at the end of the day, that's why you're going to cloud. The same reason we went from bare metal to virtual machines was for efficiency and cost savings. Hopefully you're doing that for cloud as well. And third, it's easily updated and maintained through that CI/CD pipeline that we made reference to previously. And of course, fourth, it needs to absolutely be secure. And so we have 5 principles that we're asking you to go ahead and embrace. And those 5 principles are covered at depth in a very great blog post, which will be available in this presentation once it's presented or available for you guys for download later on. So the first principle is designing for automation. Oftentimes human error injects or introduces a lot of failure or a lot of errors. So if we can go ahead and automate, it absolutely requires a higher upfront investment to automate. But once you get that automation in place, it's reliable, it's repeatable, and it'll absolutely pay off in the midterm or medium term. So automated systems tend to work faster than humans. So there are a number of different things. As I mentioned earlier in the pipeline, software developer makes code changes, commits it to a repo, there's some build facility or some third-party facility that's watching for an event of such as a commit, it's going to go ahead and be triggered and run some testing or build process and so forth from there. Excuse me. So design for automation. Second principle is be smart with state. Nowadays, most of the systems that are being created are expected to scale and to be elastic or auto scaling and dynamic, because you never know what volume of demand may be delivered or may be placed on your particular service. So one of the things that we practice here at Google is that we try to ensure that whatever code is being written, whatever logic is being implemented, can scale and can scale to billions of concurrent users or billions of users over a shorter period of time. And the reason why we're asking you to be smart with state is because state maintenance can be expensive. Truly think about whether or not state is needed, or it can be offset and persisted to some other facility, another service, hopefully that scales as well. One of the patterns that we're also relying on that I haven't made reference to here yet along the way is a microservices pattern. Let's go ahead and create atomic services that can communicate and rely on other services rather than creating a monolithic code base that has to be written in a single language and managed by a single team. And folks would have to reverse and understand if they're going to make change into that environment. So you're smart with state. And then principle number 3, using managed services. With Google Cloud, our hope is that not only are you leveraging all of our cloud-based infrastructure, but once you have a feel for that infrastructure and you realize the value in allowing us to maintain that infrastructure, you're also going to take advantage of some of the managed services that we offer. In some cases, going back to the previous principle of being smart with state, state is often maintained or provided via databases, be they relational databases or NoSQL databases. Why not leverage a cloud provider's managed offering of that database or that persistent storage capability, because you no longer have to do that if you rely on that managed service. Again, you can focus on your core business and the logic that's needed from your development team. And then beyond the managed services, of course, we want it to be secure. So let's ensure that we're practicing defense in depth. No single control is going to protect you from all attacks or all potential threats that are out there. So even in our environment, we have a huge stack of controls. Some of them are duplicates, but sometimes it's there based off of the channels of those attacks or those threats. So let's ensure that you have that coverage. Your perimeter security builds, trusted and untrusted boundaries. Your cloud native design is going to go ahead and favor that immutable infrastructure so that you know with high level of confidence that all of your assets within a managed environment or a self-managed environment are the binaries that you intended, are based on the artifacts that you have in your repository, and you can trust that, rather than having 10,000 virtual machines that are out there that were either built manually or were built via automation 2 years ago, but now have drifted drastically from their incept because folks have logged in via SSH and made changes, or folks have RDP'd to them and made changes and installed new packages. And not only this bottom bullet here is very important, not only does the application need to be secure, but the infrastructure needs to be secure as well. And then the last principle is that change is a constant. And because change in the environment and the process is a constant, you always have to revisit the architecture and the patterns that you're embracing and you're adhering to. Change is absolutely constant in our environment, and I'll get into that a little bit later. But in this case, consider limiting your ingress. There's a number of different products that I make reference to here within cloud to help really reduce the attack surface for a given workload or a given web-based service, if we're talking about web-based services. Also, again, making reference to the microservices pattern, you're reducing the attack surface by breaking them up into smaller services that can be dependent or reliant on other services. And then you can control and gate ingress and egress for each of the appropriate services. Making reference on this third bullet to some of the managed services that we have in our environment. So if you shift the management responsibility, the operational responsibility to your cloud provider, you can then again focus on your business logic and monitoring and being ready to respond, assuming you end up with some event at some point in the future. And then there's the infrastructure and the bus for access to your logging, making sure that you have that evidence emitted into evidence being your log events, be they platform, cloud provider log events, operating system log events, your auth events, or even your application log events, getting all of those signals into some platform that you can then review and analyze. And the CSCC in this case is an acronym for the Cloud Security Command Center. I'll make brief reference to that a bit later. But once you have these 5 principles and you start thinking about them, you then realize how much change can be affected by those 5 principles. I like to share this slide to show you some of the numbers of the change that occurs within this environment. And my hope is you look at these numbers and you realize that these metrics are quite large, and that is a significant amount of change. And then I'll share with you that these numbers are 4 to 5 years old. We've not yet published our recent numbers since 4 or 5 years ago.
Hey, Eric.
Yes, sir.
Questions come in behind the scenes here. A lot of the attendees out there didn't grow up, didn't earn their stripes in a software development background. And so some of the terms may be a little new to them. One of which is when you talked about managing state and when it's required and state management, I wonder if you could expound on that a little bit and help define for the audience what state is and what state management is.
Gotcha. So when most of us think about a web service or a web application, very often for anything that's important or potentially touches either critical data or a critical process, there's this concept, you'll typically have to authenticate or log into this service. And that authentication is a form of state, assuming it's successful. And in addition to state of that authentication or the status of that authentication, anything that you would need to maintain kind of in history for that given session would be another value that might need to be maintained in state. If you can think about when you're surfing a website and it's asking you about cookies, cookies are a method of using and maintaining state or persisting state locally. Typically, it's just an identifier that is then used to identify your browser instance, your browser session on some backend service. But that's what state is. Anything that you would normally write to a file, to a database, to a memory store, as an example.
That's why it's so important for young security professionals to understand what each of those layers, like whether you ascribe to the OSI layer or not understanding what's in each one of those layers, what's happening.
Absolutely, absolutely. And it looks like Jeff's got another question regarding how often we would recommend scanning base images in that pipeline. So Jeff, I would leave this up to your businesses or your organizational's vulnerability policy. Typically, if an organization had a vuln policy that said any high or critical severity vulnerabilities need to be addressed with an end period, let's say end period is 72 hours of being identified and discovered. If that's the case, then I would ensure that those base images are evaluated at that frequency. And the hope is that ultimately you end up with a pipeline that says anytime the underlying dependencies or packages within that base image change, if there's a new release or there's a patch that's been applied, the automation in that pipeline can perform that scan on your behalf and simply emit the report or the data that you need in a report to make a decision. And hopefully we can take the human out of that, but we understand that as you're embracing this and you want to learn and begin to trust the process, you can inject that human for manual approval. So I would say, let's start off with, maybe not quite a daily basis, but at a minimum, rescan them on a weekly basis. And the hope is that you have a collection or a repository of a smaller set of base images that you're relying on. Rather than having 300 base images, you really have 7 that you truly need because of your workloads, because of the languages that you're using and so forth. I hope that answers your question there, Jeff.
Eric, we have a number of young developers on the call here today, on the webinar today, and some of them will look at these principles and they're going to go, well, how do those relate to me? I mean, generally I go into, as a young person, I go into a team and somebody's giving me those software patterns. They're giving me those software, the guidance for software development. But then, so they go into an environment like this and you start using terms like atomic and immutable infrastructure. Those were 2 the questions came in the background to me. Can you just describe what is atomic? What is an immutable infrastructure?
Gotcha. So when I was making reference to atomic services, or you take what would have been traditionally maybe If you've learned in the last few years, you may have learned about LAMP style applications, LAMP being Linux, Apache, MySQL, and PHP applications, where you would typically have a presentation layer that delivers style sheets and HTML out to the end user, the consumer of your service or your application. And then you would have the business logic written in your PHP or your Python code, in some application tier. And then you would have the database as your persistence or your state management layer as well. And what we're asking for from an atomic standpoint is that go ahead and decompose that application into the smallest units of business logic that makes sense and that are reliant and capable on their own. Something that's atomic, that may have external dependencies to progress in some larger scale application. But let's say if I were writing a calculator, I might write a routine or a class that simply performs addition. And then I may write another routine or a class that performs multiplication or division or subtraction as an example. And so each of those classes would be atomic in that sense.
It's easier to write more secure code that way and test it.
Absolutely, and it's less code to be reviewed. Yes, it ends up with more objects or more classes, but they're smaller. It's less risk on each individual class itself. And hopefully, when you have a problem with the calculator and you identify that it's in the addition class, you don't have to understand one giant calculator class. You simply need to understand and appreciate the addition class itself. And then when you ask about the immutable simply means unchanging or incapable or of changing a particular object. So if I build a server and that server gets deployed or provisioned into a given environment, it means that I'm not touching that server from a sense of logging in via remote desktop if it's a Windows machine, or via SSH if it's a Linux or Unix machine, and manipulating the configuration or installing new packages on that server. If you're making that change, you're mutating that configuration, you're mutating the state of that server or that virtual machine. And so rather what we're asking is that you make those changes or those mutations earlier on in the process. So every second Tuesday of the month, Microsoft comes out with their Black Tuesday patch updates. So what we would ask is that after those patch updates, you obviously perform your tests and so forth. If you have a Windows environment, you then build new images based off of those images that have been patched from that Black Tuesday event. And then you use that going forward and you build on top of that. So rather than deploying those packages or those updates into your production environment, you build them as part of the artifact and then you deploy and reprovision that artifact going forward. Does that address the immutable question there?
Thanks, Eric. Yeah.
No, not a problem at all. Okay, so I got to the fifth of always be architecting, and I hope you all appreciate why, because change occurs. Just an example here of how change is a constant within our environment and our peers' environments in the other cloud providers. And then I'm sure a number of you have heard these terms here: app dev or application development, DevOps being development operations, or even DevSecOps, where we've attempted to introduce security into the DevOps concept. And what I'm saying here is that whatever you're calling it, let's move security farther left into that process, and let's make sure security is there, whether it's referenced implicitly in the name, the concept itself. Let's do a better job of getting it there. And something else to keep in mind is that even though we may truly embrace DevOps, DevOps is not all the things. Agile is not all the things. Okay, sorry, I'm reading another question from Jeff here. Okay, Jeff, I'll put that on hold and see if I can answer that towards the end of the presentation as well. Okay, so as I mentioned, DevOps is not all the things, nor is Agile. Agile as a methodology or a framework is not all the things. Somebody in your business organization has this great idea, they pitch the business on it, they get the support for it, you begin your Agile process, creating your backlog, start working from that backlog from a development standpoint, and then ultimately moving it from development into operations and then out to your consumer market or your customer market space. And so this is just a quick diagram to show you that Agile doesn't solve all of this. DevOps doesn't solve all of this. There's absolutely the ability to inject security concepts and controls into each step in this process. From a conceptual standpoint, you can begin your threat model. From a business standpoint in this flow, absolutely require, even if it's just a verbal or oral tabletop threat model, walk through what data am I touching with this service? What application am I impacting or relying on as well? What development teams do I need? What experience do those development teams have? And what tooling do I already have in place that these various development teams are relying on? Okay. And so rather than trying to inject security into whatever app dev, DevOps, ops dev, aggregate contraction you want to use here, I'm asking you to wrap security around it all. And as we mentioned earlier, there are the 5 principles, and to go along with those 5 principles, there are 5 phases in a cloud native application with pervasive security. You have to design the application, you have to develop the application, you have to deliver the application. Delivering the application is actually deploying it to an environment and making it available for the consumers, the end users, be they internal or external facing. And then somebody has to operate that application. They have to be able to monitor it, to make sure it's up and running, to make sure it's performant, to make sure it's secure, and there's no bad actors or attackers within the environment. And then in the event of failure or your metrics trending in the wrong direction, hopefully you have an operational team or an SRE, the site reliability engineers, that can help to determine what's going on and how to address it and how to ensure that we close that feedback loop and fix it up front so that it doesn't happen in the future. Okay, and so the next couple of slides, I'm going to skip through pretty quickly. As I mentioned, they'll be available, or once this recording is out there, you can pause. The idea here in these next few is I'm taking app dev, ops dev, and focusing on app dev, DevOps, and then ops dev, and just giving you the bulleted list of what areas or what concepts may apply within those 5 different phases of designing, developing, delivering, and on from there. Okay, and I'll leave them on screen just long enough for you to go ahead and pause and actually read them. Okay, and now once you've adhered to those security principles and the pipeline for securing your application, I actually now want to share some of the security controls and some of the concepts that we practice within cloud, within Google Cloud specifically. And we, not too long ago, went ahead and performed a survey across our customer base to ask them what threats they were really concerned about within cloud and within their organization. And so these are the top threats that came up. The top 2 were hit really, really, really high. And so I'm hoping those of you on the session that these will resonate with you, or there's definitely some interest in asking how each of these are actually addressed. How do you address them on premise today? How would you address them within public cloud, whether it's AWS, Azure, or GCP? And then from a Google Cloud standpoint, we start from a protection. We want to ensure that our underlying infrastructure, because we're asking you to trust us at the end of the day, is designed secure from day one. And I like to sit on this slide just for a second, because you all know Google started out of the search space. And so when we decided to enter into the enterprise cloud space, the business cloud space, not so much the early days when we did cloud just for development and community, but when we actually decided to take cloud seriously and enter into it for enterprise, the revenue that was generated within Google was really coming from search and ads. And that organization told us, if you're going to enter into cloud, you have to do it right. In order to do it right, you have to do it securely. And we couldn't put any of that at risk. So this is why this is top and at top of mind for anything we do within Google Cloud. And I'm glad, Adam, that you made reference to the OSI model. For those of you on the call, or those of you that are students, if you've not yet heard of or studied the concept of the OSI model from a networking standpoint, I ask that you go and spend a little bit of time at least taking a look at it. It's a very, very great model that walks you through what it takes to get a networking signal from the physical layer all the way through to the application layer. And there's 7 layers in there. A number of us in the community like to say that layers 8, 9, and 10 are people, process, and beyond. So what this is this is our equivalent of the cloud or the Google Cloud OSI model, where at the bottom we start with hardware. Once that hardware enters into our environment, it boots, and hopefully it's booting securely and we trust it. And there are a number of things that we do to make sure that that's the case. Then you get your operating system. You need storage because you're persisting these files, that operating system. You need a really, really highly available, low latency, wide bandwidth network. Then you need a number of different applications. You need your deployment options. You need your operations. And then obviously you need your consumption, your usage on top of it. So if you were walking through some sort of a cloud provider or cloud engineer training program, you're going to learn about all of these, whether it's at GCP, AWS, or Azure. We all do it a little bit differently based off of our expertise. And then this is just an example, again, of that same OSI model with some of the various security controls and security and networking related products that exist within GCP. Again, the other public cloud providers have their comparables, but these tend to show you where we see on the storage layer, the fourth one up from the left, the very first blue box says encryption at rest. If you're writing files to a file system, or you're writing files to persistent disk, what would normally have been the SSD or the spinning hard drive within your laptop, in this particular case, you want it encrypted. You need it encrypted because there are a number of different regulatory frameworks that require it, and it's a lot more secure. And if your data is being trusted within our environment, you absolutely want it encrypted. So we do that by default for your data at rest on our highly available and distributed network-based file system that supports storage. Okay, and Julie's asking, okay, absolutely, Julie, I'll make reference to that at the end of the session there. Okay, and one of the things that I'm really proud about at GCP is that we can actually claim end-to-end provenance of that OSI model equivalent for a cloud. And when I say purpose-built chips, we're not creating the CPU. Intel and AMD are doing that for us, but we're actually purpose-building the servers. We actually build our own servers. We've designed the boards. We take Intel and AMD's chips, but we have created a chip that we call the Titan security chip that sits right alongside that CPU. It will hold that CPU in reset, meaning that server can't boot until that Titan security chip verifies the integrity of the code of the binaries that are about to run on that CPU before it can even boot, an operating system. And then, as I made reference to earlier, we have purpose-built storage. We have low latency, high bandwidth, highly available network-based file system. And then we have a purpose-built network as well. It's a multi-petabyte based network, and we absolutely have purpose-built data centers as well. Trying to keep this from being too much of a sales conversation. And I already walked you through this hardware infrastructure on the secure boot. On power on, that Titan security chip is going to go ahead and verify the integrity of the hardened BIOS and bootloader and kernel before it can actually run on that CPU from Intel or AMD. And I also already made reference to the encryption by default. In our environment, you cannot disable encryption. It's there by default. You can change the way that encryption is managed. We allow you to manage the rotation period of the keys that are used for encryption, or we even allow you to bring your hardware-based HSMs into our environment, and then you can add that into our key management fabric, and then you can control it from that the command line interface for your HSMs. And again, in the middle here, you see that OSI model stack there. But in this case, what we're trying to express is that security, again, is a shared responsibility. And the columns are showing the differences between who's responsible for all of these levels or layers in this stack as you move from an on-premise environment to an infrastructure as a service environment, to a platform as a service environment, to a software as a service environment. So if you can think of as on-prem, you're building the bare metal or virtual machines on, within your data centers or within your offices. Infrastructure as a service is where you're simply using either AWS's EC2 instances or GCP's GCE instances, and you're simply using our virtual machine capabilities, but you're still managing the operating system and the applications and the packages. The platform as a service is where you're now taking advantage of some of our storage capabilities because you're simply treating it as an object-based store, or you're treating it as a database. It's interacted with the same way as a database on-premise, except we're now managing that for you. And then software as a service, you can think about it, hopefully a number of you are also Gmail consumers. At the end of the day, Gmail is a SaaS offering. You're simply only using the web-based interface. You're not responsible for making sure that you've got enough memory or compute or storage behind that Gmail service that you're consuming. Okay. And then one of the other controls that we have that's key and critical to all of the public cloud providers would be your identity and access management. Who has access to it? Where do they have access to? What's the scope of that access? And then what roles do they have access within those assets and so forth? And so in our environment, we have this concept of a cloud organization or your enterprise. And then we have these concepts of folders that are logical containers for organizing business units, lines of business, major services, or larger product areas. And then we have this construct in the green there of projects. Projects are actually where the GCP resources or assets are provisioned. They actually exist within a project, and a project doesn't have to be in a folder, but it can. Folders are there to provide structure and organization. And we also allow you to define security policy based off of the organization, folder structure, project structure, and in some cases, even at the resource level. And this is yet just another example of what that might look like, in an organization where you have your departmental folders, your teams within department and products, and then your projects. And then maybe at the project level, you're splitting them out by environment, your development, your tests, and your production. And there are reasons you may want to do that because in our environment, a network is bound within a project. A network doesn't cross projects. You can actually bridge networks across projects via VPN or interconnects or other routing facilities. But normally when you define a VPC network or a virtual private cloud network, that exists within a project. Okay. And then this is just a high level overview of some of the various controls. This one I can spend a good half an hour on, but I just want to show you that in cloud, oftentimes when folks ask what cloud is, cloud at the end of the day is really a third party providing you virtual infrastructure. I'm giving you compute, I'm giving you storage, I'm giving you network, and beyond that, I'm enriching that infrastructure with other platform or software as a service capabilities, and we expose those as APIs. And so those APIs don't get provisioned within what would normally be your VPC network. Those APIs oftentimes exist within a multi-tenant or your cloud providers, infrastructure that they're managing for all their customers, or at least a subset of their customers. And so certain controls aren't available to you for the APIs. If I deploy a virtual machine, I can place a firewall on that virtual machine and ensure that TCP 22 ingress is available for that server. But if I have a VPC service, or if I have an API service such as BigQuery, which is our managed data warehousing platform, I can't write a firewall rule to put in front of BigQuery because that API is a global publicly accessible service. And so in order to do that, we had to create a capability that allows you to define what we call VPC service controls that are comparable to a network-based ACL or firewall rule, but you can do other things. I can now say, I'm only going to allow Adam to access my non-critical, non-protected data from this BigQuery database if he's coming from the Americas. But if Adam is coming from Mexico, I'm not going to allow him to have access to that at all. Because I know, Adam, you're looking forward to going down to Cancun real soon, right? Okay. And then this slide is an eyesore, but this slide covers, at a very high level, 13 things to keep in mind if you're entering into GCP. And number one being unifying identity. So you absolutely have to figure out where your users are coming from, what roles those users will have, and what scope or access those users will have as well. And I'll leave this one up for a bit because it'll make sense to to review either in the slides or in the video recording of this session. Okay. And again, all cloud providers are giving you options to go ahead and write security policies to secure access into those resources. This is just an example of us where we're giving you options from that end user through their ISP, through that POP, through what we call the Google network or our Google front end, the GFE. And we'll have coarse grain controls as well. And then we'll also have fine grain controls, and that'll be represented, I believe, in this next slide here. So as an example, that global load balancer, let's say you have a web service that you want available to public. It's a publicly accessible web endpoint. So you're going to use our global load balancer. That same style of access controls that you can use for VPC service controls, you can then configure for a global load balancer saying, I only want traffic because I'm using a third-party content distribution network such as Akamai, and my origin servers are going to sit within GCP. So I'm only going to allow traffic from Akamai to this global load balancer because I don't want folks from Cancun hitting these services directly. I want them to go through Akamai, as an example. Okay, and then this simply walks you through how we can move from those coarse grain controls to your fine grain controls. So I can say from a coarse grain standpoint, I'm blocking it based off of network, I'm blocking it based off of geographic region, but then I can get down to fine grain microsegmentation because I can actually tie them specifically, as I did in the example of Adam from Cancun. I actually write policy that not only keeps everybody from Mexico having access, I can ensure that only Adam has access to it from the Americas. Okay, and then again, going back to identity and access management, your users, their roles, their permissions, and their access in the environment, there's this concept, you've heard us talk about zero trust, you've probably heard the concept of least privilege, of making sure that I don't over provision access or permissions to the environment. No, if Adam only needs access to one server or a subset of that server, I don't need to give him root access to everything in the environment. And so we want to have a number of different capabilities that help you restrict and really narrowly scope what Adam can do and when Adam can do that. And so we do that as an example. You can restrict roles on your production workflows. You can, in our case, we have this concept of atomic atomic roles, and then predefined roles are curated, because the atomic roles came out back when we were really focusing on the development community for cloud. We now have these predefined roles, which are curated and have a subset of what would have been the higher level atomic roles. And then these roles also allow you to create these custom roles where you can now say, look, even the curated predefined role is too broad or too over provisioned. So now I really want to focus on what Adam truly needs to do in this environment. And then you can limit where you actually assign these as well. You can assign them, as I made reference to earlier, at a resource level, at a project level, at a folder level, or at an organizational level. And of course, we want to help you get to least privilege. And in order to get there, we've created a number of different products and features within our tooling, within our platform, that help you get there. So upfront, having you understand where you've over provisioned, or what assets you truly have in your environment. One of the things that's really different from what might be your data center, an on-premise environment or your data center, at least years ago when I was working in data center environments, it was really easy for anybody in IT that had access to that environment and keys to the racks to install new systems. As long as there was power, as long as there were ports on the switches and they had access to the networking, you could get a new server installed into an environment, as long as you had the space and the power and the cooling capabilities. And oftentimes the individuals that were responsible for managing it from a total asset inventory, or what we used to refer to as a CMDB, or the configuration management database, maintaining that inventory, they didn't know how many of the 5 or 20 or hundreds of folks that had access to that data center were deploying new assets into that physical data center, or in today's world, into the virtual data center, your VMware pools, you deploy new VM instances or new tests and so forth. So there may not be one single place to go and pull that inventory itself. But because the public cloud providers are creating one organization, one set of credentials for this particular environment, or sorry, a set of credentials for each user or each non-human entity, everybody's operating within the same enterprise or the same organization. We can go ahead and say, look, Adam made a request for these 20 instances at this point in time, and maintain full history of all of the mutation or changes that have occurred. And all that attribution exists in what we refer to as a cloud asset inventory service, which is exposed within the user interface, the web-based cloud console, as well as via an API. So programmatically, you can write Go code or Java code or Python code, or simply run our command line utility that we refer to as G-Cloud, and take all that inventory data and put it into whatever database you want if you're merging it from other cloud providers or even your on-premise CMDB. So, and then we have this concept of, what went wrong in this second column here. We have a tool called the policy troubleshooter that why was Adam able to gain access from Cancun? He shouldn't have been able to. I didn't expect that. You can use policy troubleshooter to figure out which policy is missing or which permissions were enabled because of a role binding that were outside the scope of that policy. And then again, there are a number of different tools to help you up front proactively identify that blind spot sensor, like validations. If I make these changes, what's the impact? Will Adam be able to access it from Cancun? No, I'm sorry, Adam, for picking on you. And then at the end here,
I'm used to it.
at the end here, making it easier from a permissioning standpoint, we have a tool that we call the IAM recommender. So after a 45 or 90-day window of usage, we can go back and say, look, I've over provisioned Adam's access because I gave him 3 role bindings that had 2,000 permissions. And in the last 90 days, he's really only used 12 permissions. So maybe this curated role is a better fit, or consider creating a custom role with just those 12, or even because of those 12, he's likely to need these additional permissions. So create this custom role with 20 permissions instead of the 2,000 plus that you did give him access to. Okay. And again, this always comes up from a trust standpoint. Yes, we're Google Cloud, and yes, we have consumer services, such as Gmail and what was G Suite, which is now Workspace. But from a business or an enterprise, as you engage and interact with any of the public cloud providers, you're entering into a contractual relationship. So your data is your data. We're simply your contracted provider and processor. We don't touch or use your data. If we touch your data, it's a result of a support incident. And in the process of touching it, there's a number of different controls that are in place. There's a limited number of folks at Google Cloud that have the ability to, and there's a number of steps and processes that are in place before they can actually touch that data, if for some reason they have to. And some of that we call access transparency. So if for some reason in the act of fulfilling the effort needed for a given support case, we happen to touch your data, you're given a report that support engineer X came close to your data or touched your data. You do also, as an enterprise, have the ability to say, you know what, I want to know before Google support engineers or software engineers even come close to touching my data. I want the ability to make the decision if I want them to or not. And so that's an option within our environment. And at the moment, I'm happy to say we're the only cloud provider that offers that. That'll be my only sales pitch in this session, I promise. Okay. And again, I'm simply restating here, you're the data controller, we're the data processor. It's your data. We're going to follow your instructions contractually and otherwise. We have strict internal policies on how your data is handled. I made reference to access transparency. It is a product with a number of different features and capabilities to ensure that that's in place and to give you the visibility and audit of when that data and if that data needed to be touched. And along that, there were a number of different third-party audit certifications and documentation that we've gone through because our customers and regulators expect this independent verification of our privacy and controls, compliance controls. And so we go through this independent third-party testing and assessment on a regular basis. And so this is just an example of some of the regulatory frameworks and certifications that we are compliant with and assessed on a regular basis. Okay. And we have regulatory engagement. We have resources on teams that specifically engage with these, not only to ensure that we maintain a solid relationship, but making sure that their frameworks are actually considering the risks and maybe even rewriting some of their standards or their requirements to ensure full coverage of what's going on within cloud providers, ourselves included. And that's the end of my session. And I know we only have a few minutes left. Julie, we absolutely have a number of different certification options, from a cloud analyst, a cloud engineer, and a cloud architect. What I'll do is I'll work with Adam and team to get a set of training and certification links to share with you, so that you'll have access to that as a follow-on to this session. And then Jeff, what I would say to your question there is, you've already done a great job of starting out by attending this session. Don't be shy. Get out there. As a resource, as a security resource at Google, I took a slightly different path than most of my peers and most of the folks at Google. At Google, we call each other Googlers. And normally, Google is very heavy on software engineers. Probably 75% of the organization are software engineers. But as a security resource, as I mentioned early on, I've been in industry for 28 plus years at this point. I've been at Google a little over 3 years. My path to Google was such that I'm not officially a college graduate. I did begin school, but because I was in the Air Force and some of the opportunities I had in front of me, I took a very different approach than a number of my peers. I absolutely recommend not taking the path that I took. It was definitely a lot more challenging with more hurdles than hopefully the path that a number of you have ahead of you, assuming you're coming out of school or in school now. But network, go to these events, read, get involved, take a look at what certifications are out there as well. Don't be shy. Don't be afraid to reach out to myself, to others in community. The complement of speakers that Adam has been able to recruit and the team's been able to recruit on this session is amazing, myself excluded. So reach out, talk to them, and don't be afraid. Just put yourself out there. I think networking is what has helped me tremendously in my career. And it was because of networking that I met Adam and team. So thank you very much for this opportunity, Adam. I appreciate it.
Erik, thanks. I know you just distilled the new 5-day cloud security class that you're working on with us into 55 minutes. But for the audience, you'll see in the exhibit hall, we have a new cloud security class coming up that Erik has helped architect. We had a leader from Microsoft, a leader from IBM, and a leader from Amazon help us architect that class. But a lot of the credit goes for Erik. It's a much more in-depth class. So thank you, Erik. I know that was a lot. But again, the way Erik went through this class is this session is so that you can look at the recording and pause with the slides, which we'll also distribute. So Erik, thank you. Thank you so much.
Not a problem. Thank you all very much. I appreciate the opportunity.